What are the domains for each of the following functions? Here's one function, here's the other function. What are the domains? What are they asking? What are they asking in other words? When you ask a domain question, you're asking for the OK x's. Which values can the x be replaced with? And there are only two things you look out for. Just make sure that when you replace this x with a number, you don't provoke a division by zero or a negative under the square root. Just avoid those two types of x values, the ones that give you a division by zero when you simplify, or a negative under the square root. So let's try A. So we need to find the OK x's under the square root. So what you do is you take the radicand, that's what's under the square root, this is the radicand, you take that, and make sure that it's greater than or equal to 0. So you have to say it's greater than or equal to 0. Because you could have a 0 under the square root. Square root of 0 is 0, no problem. Or you could have the square root of positive numbers, but you cannot have square roots of negative numbers. So x plus 1 should be greater than 0, in other words, positive or equal to 0. Solve for the x. So move this 1 over by canceling the 1 here by subtracting, and subtract the other side by a 1. So when you simplify, you have that all those x's that are greater than or equal to negative 1 are going to be OK for this function. Another way of writing the domain, this would be the domain, the OK x's, is using sets. This is set builder notation. And using this form, this would read, the group of x's you could pick are those x's such that, this vertical bar means such that those x's that you picked are elements of the real numbers or members of the real numbers and are x's that are greater than or equal to negative 1. For B, we approach the problem the same way. So remember, when you're asked the domain question, just avoid those x's that provoke a division by 0 or a negative under the square root. So you take what's under the square root and you say this should be greater than or equal to 0. Then solve for the x. Notice this negative means a negative 1. There's a negative 1 here. So I'm going to move this negative 1 to the other side by canceling. And I cancel by dividing by a negative 1 here and a negative 1 here. This negative 1 cancels with this negative 1, so that gives you the x all by itself. 0 divided by negative 1 is 0. So now we know which x's are OK to substitute into this place. Those x's that are less than or equal to 0, if you plug them in here and you simplify, will give you either a 0 or a number greater than 0, which means positive. In set notation or set builder notation, this is the way it would be described. The group of x values are those x's such that those x's are members of the real numbers or elements of the real numbers and are those x's that are less than or equal to 0. So this is the domain described using sets, a set notation form or set builder form.